Whenever we graph quadratics in vertex form, we're looking at the form of this equation. So f of x, or y, equals a times the quantity x minus h squared plus k. Now we get a few pieces of information from this equation that makes it really easy to graph. First up is the direction that the parabola opens. Now, if the a value is positive, that tells us the parabola will be opening up like the one we have off to the right here. If the a value is less than 0 or negative, then it's a parabola that's going to be opening down. We also get the width of the parabola from that a value. If the absolute value of that a value, or just think of it as the positive value of it, is greater than 1, it's going to be a more narrow parabola. If it's between 0 and 1, it's going to be a wider parabola. And what's happening here is we take this parabola, and as we stretch it by having a larger a value, it makes the parabola more narrow. So it's not a multiplying to make it wider, but it's a stretch, a vertical stretch of that parabola. The last part, and probably the most important, is the vertex is hk. Now, we went x minus h in here, so we're going to take the opposite of whatever value is inside the parentheses, and then the same sign that's on the end. So we're going to go through and kind of sketch out the graphs of a few of these. So first one we have is the negative, the quantity x minus 3 squared minus 1. First up, we have the vertex. In this case is positive 3, negative 1. We take the opposite sign on the inside, keep the same. So if we look, we go over 3, down 1 to get to our vertex. Now, from here, we need to find other points. So we know 3 is the x value that we use. If I plugged in, let's keep 3. We know 3 goes to negative 1. If I went to either side of 3, so I went to 2 and 4, and substitute values in, this becomes, we'll do the 4 first. 4 minus 3 is 1. 1 squared is 1. Becomes a negative 1. It's then negative 2. If I put in 2, I get 2 minus 3 is negative 1. Square it to be a positive 1. Make it negative 1 with a negative 1. That's negative 2. So it looks like we get 2 negative 2 and 4 negative 2, which follows the negative value, so it is a parabola that opens down. Missed the point. There we go. What we also notice is they are symmetrical along this axis of symmetry. It went over 1 unit in either side, and also the amount that it went down in the first step from 3 to 2 or 3 to 4 was negative 1, which is the same as the a value we had here, because a was equal to negative 1. Now that's a little hint or a little shortcut we can use to make it easier to sketch these graphs. It doesn't work to find the other points. If we plugged in 1 and 5, they're not going to change by 1 because it's going to keep getting steeper. But for right now, if we're just sketching these basic parabolas, it's enough to help us out. So let's go to the next one. Vertex is going to be negative 3, positive 2, opposite sign, keep the same. So we're going to go negative 3, positive 2 to right there. Now, we look, negative 2 tells us it opens down. I'm going to go down 2 units. So I'm at negative 3, 2. So I'm going to go negative 2, 0. And negative 4, 0. Went down 2 units on both of those, and that allows me to sketch the graph to find what the points go through. It's not the most exact representation of the parabola. You need to make sure it is getting steeper as it goes. It's curving that way. But it's enough for right now to understand that, because there's really 3 things we have to understand a parabola. We need to know where the vertex is, we need to know the direction, and we need to know the width. If we can kind of look at an equation or a function that we have and identify and describe these 3 and allow us to compare them, that's enough for right now as we're sketching them out to understand them. So let's look at some more. Next we have x plus 2 squared plus 1. So our vertex is going to be negative 2, positive 1. So we go left 2, up 1. Now our a value is 1, so I'm going to go up 1 unit on either side. So that's negative 3, 2, and negative 1, 2. There's my parabola. Next we have negative 1/4 out in front of x minus 1 squared, and then plus 4. Vertex is going to be 1, 4. Change the sign, keep it. So let's find that point. So 1, 4 puts us about here. Now a negative 1/4 tells us it's opening down, and the a value being negative 1/4 means we're going to go about 1/4 of a unit to either side. Now it's an approximation in this sketch, so I'm just going to say it's about right there and right here. So when I draw this, I know because it's negative 1/4, it should be wider than another parabola, maybe like that one up above. Now they do open different directions, but I can clearly look and say that this second one is wider than the first one. It should be because the a value here is 1, where the a value here is 1/4. In our third one, we have the vertex is 5, negative 3. So 5, negative 3 puts us about there. A is 3, so we're going to go up 3 units to either side. So that's going to be at 6, 0, and 4, 0. We sketch a parabola, and we see that it is opening up. Now, that was a 3 compared to the one above it, a 1/4, and the one to the first one of the page, which was a 1, and I can look at the 3 of these and see that this third one is definitely the most narrow, and it should show that, and you should be able to identify that between the 3. Last thing, we do have to identify some certain parts as we go through, and we'll use this one as an example. Whenever we talk about the domain of a parabola or a function, we're looking for the x values that work. For what we're doing right now with parabolas that open up or open down, they will always have a domain of all real numbers. The range is the y values that exist. Now, when this parabola opens up, there's a minimum y value that we have. So y is greater than or less than this negative 3, because that is the lowest y ever gets, and everything else is above it. So y is greater than or equal to negative 3. If I looked up at this problem, I would say that the range, because the vertex is 1, 4, and it's opening down, the range is going to be less than or equal to 4 here, because it reaches a maximum of 4 and then goes down. So it's just the difference between the two. If it opens up, it's going to be greater than or equal to. If it opens down, it's going to be less than or equal to. Another thing we may be asked is to find the minimum or the maximum when x equals a value. Now, if it opens up, it's always a minimum. And the x value when it hits the minimum, in this case, is 5 because it's the x value of the vertex. In the problem above, we would say it hits a maximum, because it opens down, it reaches a peak. It reaches that maximum when x equals 1. Again, the x value in the vertex. The last one, we may be asked for the min or max of the function. In this case, where x was used before, now it's the y value of the function. So again, it's the minimum. The minimum of this one is negative 3. So we'd say the minimum of the function when y equals negative 3. Up here, we'd say the minimum of the maximum of the function is when y is 4. Notice these two values are the same. The minimum and maximum are the same as the value that's used within the range. Now, from here we had these problems that we need to graph. If you're going to solve them, I would pause it, try them out, and then I'll put the answers up on the screen in a moment. No, really, you should pause them and try them first. So our answers are, we graphed our first one. Domain for this parabola is going to be all real numbers. The range is when y is greater than or equal to negative 1. The minimum occurs when x is negative 2. And the minimum value of the function is negative 1. Again, the same as those two. We go to the second one, domain. Again, all real numbers. The range is y is greater than or equal to. Our vertex is negative 4, 2, so that's 2. The minimum occurs when x is negative 4, and the maximum is 2. Down to our bottom set, the range is when y is greater than or equal to, our vertex there is -4. The minimum occurs when x is 4, and the minimum value is -4. Last one, our vertex is +1, 1. So y is greater than or equal to 1. The minimum occurs when x is 1, and the minimum value of the function is 1.